But the major point that I want you to see right now is, and we won't worry about why I want to do this, I can define the trigonometric functions in such a way that their domains are real numbers rather than angles. And in fact, this is the main reason why people invented the notion of radian measure. Let me see if I can't make that a little bit clearer once and for all. You see, the question is this. Let's suppose I'm talking, oh, let me give some letters over here. We'll put a Q over here. Let's talk about angle QOS. That's a right angle. It's a quarter of a rotation of this circle. Now, the question that I have in mind is, if something is a quarter of a rotation, why do you need two different ways of saying that? Why do we have to say it's 90 degrees or pi over 2 radians and bring in a new measure when we already have another way of measuring circles, angles of circles? The idea is something like this. Let's again mimic the idea of taking the length t and laying it off along the circle like this. Now, here's the idea. Remember, the radius of this circle is 1. So notice that PR, in other words, this y-coordinate, is what we called by definition the sine of t. In other words, just above, we said that sine t was the length r to p in that direction. Now, the point is, I said disregard traditional trigonometry, but we can't really disregard it. It exists. For the person who's had traditional trigonometry, how would he tend to look at this length divided by this length? He would think of that as being what? It's side opposite over hypotenuse. That also suggests sine. And the sine of what? Well, the sine of what angle this is. Now, the thing is this. Somehow or other, to avoid ambiguity, if we could have called whatever measure this angle was measured in terms of, if we could have called that unit t, then notice that the sine of the angle t would have been numerically the same as the sine of the number t. And again, if this seems like a hard point to understand, we explore this in great detail in our notes. But the idea is this. You see, somehow or other, if sine t is going to have two different meanings, we would like to make sure that we pick the kind of a unit where it makes no difference whether you're thinking of t as being a number or thinking of t as being a length. For example, suppose I now invent the word radian to mean the following. An angle is said to have t radians if, when made the central angle of a unit circle, a circle whose radius is 1, it subtends an arc whose length is t units of length. See, in other words, I will define the measure called radians so that an angle of t radians intercepts the length t over here. In that way, sine t is unambiguous whether you're talking about an angle or a length. For example, when I say the sine of pi over 2 radians, what do I mean? I mean the angle the sine of the angle which intercepts a length, an arc, pi over 2 units long. Well, see, pi over 2 is this length. I'm now talking about this angle here. And the sine, therefore, of pi over 2 radians in terms of classical trigonometry is 1, but that's also what the sine of a number, pi over 2, was. By the way, this explains the convention that one says when one uses radians, you can leave the label off. All we're saying is that if we had used degrees, there would have been an ambiguity. Certainly, the sine of 3 degrees, the sine of 3 degrees is not the same as the sine of 3. You see, 3 degrees is a rather small angle, but 3 is a rather great length when you're talking about the arc of the unit circle here. Remember, half the circle is pi units long, so 3 would be just about this long. In other words, notice that 3 radians and 3 degrees are entirely different things. But the beauty is what? That if we agree to use radian measure, then we have no ambiguity when we talk about the sine. The sine of the number t will equal the sine of the angle t radians. The cosine of the number t will equal the cosine of the angle t radians. In a certain sense, it was analogous to when we talked about the derivative dy dx, then wanted to define differentials dy and dx separately, so that dy divided by dx would be the same as dy dx. That we wanted to avoid any ambiguity where the same symbol could be interpreted in two different ways to give two different answers.